Okay, I've got Cisco Packet Tracer open here, and I've created just a small local area network with two subnets. And router 1 is exposing a network on this interface, gigabit Ethernet 0/0/1. It's exposing a subnet that you can see there, 192.168.1.64/26. Its IP on that interface is 192.168.1.65. And it's got one client on this subnet, PC1. PC1 has an IP address 192.168.1.66. Router 0 here is exposing a separate subnet on its other port, 192.168.1.0/26, and it has, in turn, it's just a mirror image of the subnet on the other side. It's got PC0 connected to that subnet with IP address 192.168.1.2. So I'm going to run a quick simulation here. PC1 is going to try to send a ping over to PC0 across separate subnets, and we're just going to take a look at what happens here. We are PC1 here, and our IP is 192.168.1.66, and our gateway is 192.168.6.5, which is this interface right here. We are going to ping 192.168.1.2. That is the IP of this device here. We can see. Yep. And we are going to run this in simulation mode so that we can just see it step by step. So we can see that we've got an outgoing packet here. IP, the source is 192.168.1.66. That's PC1. Destination 192.168.1.2, which is this PC over here. We can see that the ping process starts. The destination IP is 192.168.1.2. It is not in the same subnet, so PC1 is looking around to see is there anywhere in its own subnet that has this address 192.168.1.2. Well, that address doesn't exist in its subnet, so it's going to go ahead and send that traffic to its default gateway. It's going to say, all right, my default gateway is router 1 here on this interface. Surely router 1 is going to know what to do with this traffic. So PC1 gets ready to send a packet to router 1. Surely router 1 is going to know how to get that packet over to PC0. PC1 looks in its ARP table to find what the MAC address of router 1, because remember, PC1 needs to know the MAC address of router 1 in order to send traffic to it. It knows the IP address of the default gateway, so it looks in its ARP table to find the MAC address associated with that IP address. But that IP address is not found in the ARP table, we can see here. So the ARP process is going to send an ARP request to find out what is the MAC address associated with 192.168.1.65, which is PC1's default gateway. So it sends that frame on the broadcast address. So right now PC1 only has one other connection within that network, so it's only going to get sent here. But if there were other computers on this network over here, it would have been broadcasted. That ARP request would be broadcasted to every single computer. Router 1 receives this frame since it was sent to the broadcast address FFFF, the broadcast MAC address in this network. It receives it. It recognizes the frame as an ARP request. The ARP request's target IP address matches the receiving port's IP address. So router 1 receives an ARP request. The ARP request is saying, hey, who is 192.168.1.65? Router 1 says, hey, I'm 192.168.1.65. Router 1 puts together a frame to send back to PC1 to say, yep, that's me. I am 192.168.1.65. Let's click next. It sends that frame back to PC1. PC1 receives the frame. The frame tells PC1, hey, we found the MAC address. It's this right here, 00EO BO744802. The ARP process updates the ARP table with that received information. So PC1 is going to its ARP table and it's going, all right, we now know what the MAC address is of 192.168.65. It's this. It's 00EO BO744802. So it puts that entry into its ARP table, so now it can remember next time. It doesn't have to send an ARP request next time it wants to send traffic to router 1. So that green frame has been received. Now we got a red frame right here that it's starting to build. It's going to send out another frame. It's going to send a frame here to 00EO BO744802. It sends that frame. Router 1 receives the frame. See, this time the destination MAC address isn't the broadcast address. It's actually the address of router 1. Then it unpacks it and finds an IP packet inside that frame, the destination IP of 192.168.1.2. The router 1 looks up the destination IP address of .1.2 in its routing table. The routing table finds a routing entry to the destination IP address. Let's take a look at that routing table. This is the routing table right here of router 1. Router 1 has a static route to 192.168.10/26. It looks at the destination IP address 192.168.1.2 and it says, does that IP fall in this network? Yes, that IP address does exist in this network. Well, the routing table tells it, send it to 192.168.1.249. Now router 1 needs to look in its ARP table to find out, all right, what's the MAC address? Because remember, it needs to know the MAC address in order to send traffic to the next device. What's the MAC address of the device with the IP address 192.168.1.249? Let's pull up router 1's CLI and look at the ARP table. This is the ARP table. Look, that IP address shows up in the ARP table. And its MAC address is this right here. So it's like, okay, I'm going to send the traffic to that MAC address. So it builds this frame to that address, 00A F382. And it's going to send it. And that is going to be the MAC address of router 0 over here. We can see router 0 has got an interface on gigabit Ethernet 001 with an IP address of 192.168.1.249, and the MAC address of that interface is 000A F382.05.02. So that's where this frame is going to go. So it sends the frame. You can see it going over. So now router 0 has the frame. So it unpacks the frame, looks at the packet, the IP packet, and it is destined to 192.168.1.2. So it's like, all right, let's see how I know where that IP address is. Looks in its routing table. Here is the routing table of router 0. So it looks at that destination IP address 192.168.1.2 and says, okay, is that IP address in this network? Yes, it is. Now, where do I need to go? Well, it's directly connected. I can just send it to this network directly connected on this gigabit Ethernet port. It's directly connected. So the device sets the destination, the destination itself, 192.168.1.2 as the next hop. No more intermediary hops. As we know, it needs to know the MAC address of the device that it's going to send to. So it's going to see if it knows that MAC address. Where does it go to find the MAC address? Well, it's going to look in its ARP table to see if it already knows where that the MAC address of 192.168.1.2. Here's the ARP table of router 0. And it looks and it sees, do I have 192.168.1.2 in my ARP table? Yep, it does. It's right here, 192.168.1.2. And its hardware MAC address is this right here, 0060.5C43, blah, blah, blah. So it goes ahead and creates a frame addressed to 0060.5C, blah, 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 to that MAC address. Click next, sends that frame, and it arrives at PC0. PC0 receives this frame, so it looks at the frame, it sees, yep, the destination MAC address matches my MAC address. So it unpacks the frame. It looks and it sees that there's an IP packet inside that frame. Destination address 192.168.1.2. It looks at that destination IP address and it finds that it matches its own IP address. So it has now received the traffic. This is an IMCP packet. It has an IMCP program, and that program processes the packet. That is, from start to finish, how PC1 sends a ping message across subnets to PC0. It starts by sending out an ARP request to its broadcast domain. Router 1 sends back a reply with its MAC address. PC1 sends the ping message to router 1 so that router 1 can forward it on to PC0. Router 1 forwards the traffic over to router 0 because it finds in its routing table that's where it's supposed to send traffic addressed to that network. Router 0 looks in its routing table and finds that that network is directly connected to it, so it can just send directly to that destination IP address. So it sends to that IP address and it finally arrives at PC0.